quadratic. So we know if there's a 2 in the exponent, what's the highest exponent? What's the vocab word for that? There's a D. Degree. So if the degree is 2, we know that it is quadratic. Cool. The C, my constant, remember, is up and down, but it's also here your y-intercept. Or OY, can I never remember that? Your A's in both of them is your leading coefficient. It's talking about positive Patricia, here she is smiling, or negative Nancy, frowning. So that A tells me if the arrows are going up or down. So no matter what type of form it's in, that's what that tells me. Right here is vertex form. What do you think this helps you get? The vertex. Yes. So your vertex is the opposite of H and K. The same as K. So it's the opposite sign of H, remember opposite day, and then K. So, for example, if this said x minus 3 squared plus 5, what would my vertex be? It's the opposite though, opposite. Positive 3 and 5, that's your vertex. You also can always put it into your calculator and find the bump. Remember that? Cool. Which number here is my axis of symmetry? The 3 or the 5? You have a 50-50 shot of getting it right. Yay! 3. It's your axis of symmetry, the x-coordinate of your vertex. Axis of symmetry. Does that make sense? You also know that this is your bump in your graph. Cool. Quadratic formula. If you forget how to do your x-intercept, or you don't have a calculator, or you just forgot about the table function, or you didn't buy a calculator and you don't have the table function, then you can use a quadratic formula. Do you see where it says x? Right there. You can see that guy. See, it says x. Does everyone see the x? Give me a nod that you're alive and that you see the x. That stands for your x-intercept. So if they ask for your x-intercepts, you can always use this little guy right here where you label A, B, and C and plug it in the formula. What are other words for x-intercepts? Zeros. Give me another one. Solutions. Give me another one. From the R. Not rate of change. That's slow. Something that's in the ground of a tree. Roots. Also, when we're talking about word problems, it's when like something hits the ground or lands. I know they're talking about my x-intercepts. Hits the ground, not ground. What part of this equation? Part of this equation gives me my axis of symmetry. If it doesn't give you 2 in your calculator, that's the outside of this radical. So this equation, negative b over 2a, also gives you your axis of symmetry. So that's in case you don't have a calculator or you can't remember which side it is, or you don't remember that it flips. That equation always gives you your axis of symmetry as well. And you can plug it back into your actual equation to get your full vertex. This one probably has the most that you're going to be using from the formula sheet, other than the sequences. So make sure you write that down. This is the last unit we're going over. Doesn't look like I know what's right. So let's move on. Awesome. What? Get that packet out. Yes, sir. Yes, sir. Go to page 17, number 5. How do I multiply these? What's one of the ways I could multiply them?
You can use table. I'll show you how to do that. It's a little bit tricky to use table, but we could. But how do we multiply? There's 3 different ways. We either did the box method, FOIL, or distributing. Which one would you like me to do? Box. Woo! Alright, so here I draw my box. And then I'm going to pick an answer choice. Which one do you think it is, Jordan? Just guess. Anyone? D. Okay, let's try D. So we're going to do 11x plus 8y and 11x minus 8y. If we multiply the first one, what do we get? What's 11x times 11x? 121x squared. Yes, don't forget to add those exponents. x1 is x2. Okay? What is 11x times negative 8y? Okay, so negative 88. And then you just multiply these two together, so it would be xy. Okay, what about positive 8 times 11xy? We would have positive 88xy. And then 8y times negative 8y? Negative 64y squared. Now what do? Combine like terms, so we're going to add them all together. You're going to add them all together, so you have 121x squared plus 88xy minus 88xy minus 64y squared. Okay, then what? Combining like terms. What are my like terms, Keandra? And when I combine those like terms, what do I get? They cancel out. You get 0. So we're left with 1 minus 64y. Very good, Tyreek.
Whoa, Jordan's such a good guesser. He got it right.
Jordan killing the game on his first guess.
Woo!
If you wanted to do table twinsies, the tricky part of it is that you don't have the ability to do 2 different variables in your table. So what you have to do is just pick a number for y and plug it in. So say if you wanted to do table twinsies for this one, you could do 121x squared minus 64 1 squared, and then for your answer choices, you also plug in 1 for y. Does that make sense, Terry? Does that make sense to everyone else? You just have to pick a number for y and then keep it consistent when you plug it in. But then table twinsies should work.
You also know when you look at that minus sign, if I'm multiplying, can 2 positives, I'm looking at C's answer choice, can 2 positives make me a negative? No. So C, I can cross out. Can 2 negatives make me a negative? Nope. Okay, at the same time, they're positive. So I've got a 50-50 shot of getting this right. Now, I see there's 64, and I see the last 2 constants are 8 and negative 8, and negative 16 and 16. They're not really constants. But which one can I multiply that gets me 64? 8 and 8, or 16 times 16? 8 and 8. Make sure you guys are using process of elimination.
Okay, for this one, what should we do? We're looking for these zeros, and they give us answer choices. What can we do? Plug it in. I'm going to teach you guys a trick. Go ahead and put this equation right here in the table.
Miss Thompson, what does zeros mean?
Zeros. What are our other vocab words for zeros? We have x-intercepts. What else? Solutions and roots. I heard them both. Amazing. Put that in the table. Wait. There was somebody who was not here for the last one. So I don't know if you remember that, but everybody got a new table? Okay, when you put it in table, hit enter once, twice. The very last one, when you hit table, it says ask X. So instead of auto, highlight ask X. Looks like that, ask X. No, not yet. Okay, when it says ask X, that means you can just type in these answer choices. So type in where it says ask X, you hit enter, and then you do -3 divided by 2. So hit enter.
If there's something in there, just click delete.
So you can type in -3 divided by 2. Keandra, when you typed in -3 divided by 2, what did you get?
That's the tracking form. What's the y coordinate though?
What'd you get here? Yeah. 0. What did it want you to find? The zeros. So when it equals 0, we know that's the right one. So we know that -3/2 is an answer. C doesn't have -3/2, and B doesn't have -3/2. So what do I need to ask X next? What do I need to type in? We typed in -3/2. What do we need to type in now? +1. Good. Type it in. What'd you get? Is that 0? No. Try typing in -1. Did you type in -1 or what? So it was 1. It was 1. Y'all lied to me. Oh, you said A, not 8. So when you type in 1, you get 0. When you type in -1, you get -2. So you know that's not right. So A is the correct answer. Does that make sense? The only reason that I showed you how to do ask X is normally in your table, you can't see these fractions. So ask X, you can just type in your different answer choices. Does ask X make sense to everybody? So once you hit ask X, so you do table, enter, and then instead of auto, you do ask X. And then you can just type in a number. So you hit 4, it just tells you that number, or 4 divided by 2, or whatever. All right. Next one. What is the vertex of the graph? What should I do with that function? Plug it in the table. How are you plugging it into the table if you don't have a calculator?
Whoa, I think Steven can like do it in his mind. What's the answer, Steven?
I know the answer. But I'm working.
Uh-huh.
B.
Nope.
Once you have it in the table, what are you looking for? You're looking at these points, you're trying to find your bump, or what I like to call it is a vertex sandwich. Whichever one helps you remember. The reason why I call it a sandwich is because in your table, you're looking for a number, a different number, and then the same number again. So an ABA pattern. So it would be like -9 or 8, -9, 8, or something like that. Has anybody found the vertex sandwich yet?
I think Tyreek did.
Oh my gosh, Tyreek, what's the answer? D? And then dog. Did everybody see that one? Everybody find -5 in your X. Everybody got it? What's the point for -6 in your table? Next to -6, what does it say? -33. What does it say in -5? What does it say in -4? Do you guys see how these two numbers are the same, the top and the bottom one?
Whoa, a vertex sandwich.
It's a sandwich. 2 pieces of bread, and then the vertex is in the middle. It's a vertex sandwich. Yummy. A's for days. Any questions about vertex? Finding it in a table. Amazing. Okay, this expression. Which number of items sold for the profit equal to 0? So we're just finding, you're typing that equation and finding where it equals 0. So type that equation in the table and finding where they're equal to 0.
I would do the X, my accent. Ask X. Because that way you could put in 0 and then 35 and then 60.
And then you don't have to scroll forever.
You don't
and
have
ever
to
and ever.
scroll. It's the lazy person's version, but it's okay. You're timed on this test. Right, Allison?
When you ask X for 0, what do you get? -600. That's right. So we would cross it off. When you ask X about 35, what do you get? Still not it. Cross it off. All right, what about when you ask X about 10? Oh, you got 0 for that one? What about 60? Oh, yay! We found our zeros because those equal 0. Woo! Woohoo! Next question. Solutions. Same thing. Plug it into your table and then ask X. Do you want them to do factors or just factors?
I bet you Tyreek knows the answer.
Yo, wake up. Get your heads up.
Come on, birthday boy. You're not old. You're old, but not that old.
Am I supposed to be the answer?
Hmm?
Oh, let's see.
All right, so we got C. These are our zeros. Now, if I were to ask you for the factors of this one, what would they look like? If I told you what these solutions are, what would the factors look like? When I say factors, I mean these things.
I know Tristan knows the answer. Yes, you do. You went over it. What's the relationship between your solutions and your factors, Tristan?
Opposite. Opposite day inside the parentheses because they kind of look like an O, so opposite day. So instead of -2, what's the opposite of -2? +2. What's the opposite of positive 3? Opposite of positive 3 is negative 3. Amazing. But if we were to multiply this out, there was a common factor, so there would be a 2 on the outside. But yes, just going from your solutions to your factors, remember opposite day.
You all see the difference between how C looks and how the green thing looks. Y'all see how the difference, right? One's equal to and one's written as back.
Next, what's the very first thing I have to do before I put it into my table? What form do I want it in?
Tristan knows this one.
Look at your blue formula sheet. Those two equations that you were just writing about. You have two options. You have a 50-50 shot. Which form? Standard or vertex? Standard form, yeah. So to get it into standard form, that means I want everything on one side. What do I need to move? Tristan? The 14. The way I move that is by subtracting. So you subtract 14 from both sides, and you get x squared minus 5x minus 14. Now you can type it in the table.
What do you get for Tiana?
C, beautiful.
Yay!
Yes. Amazing. Next. Okay, so now we're talking about transformations. This one can be a little bit tricky, but what does the negative do in front of a function? What does a negative do when it transforms? You can think about when you have a positive Patricia and you have a negative Nancy, what does the negative do? What does it do to the smile?
Tristan knows.
It flips it. Good job. So it's flipping it. When we talk about flipping it, what axis are we flipping it over? The x-axis. So we're looking for a flip over the x-axis. Which answers talk about a flip over the x-axis? B does. What else does? D and C does. So A is the only one that doesn't say anything about a reflection over the x-axis. So we know that that's not right. Okay? So we narrowed it down a little bit. Now, do we think that 3 in the front does something? Or did they just throw it in there for kicks and giggles? Or do we think it does something? It does something. So if it does something, that probably means that B is incorrect, because B only talks about the reflection. Look at there. We have a 50-50 shot again. So do we think this is going to be a vertical shrink by a factor of 1/3, or is it going to be a stretch by a factor of 3?
Miss Thompson, I don't see 1/3 in that equation.
Me either, Miss K, which makes me think that the answer would be D. Next question. So we have a word problem. Anytime I have a word problem, I highlight. So I'm going to go ahead and highlight that function because it seems important. And that's it. So once I've highlighted that, it asks me about what values of t best describe the times when the disk is flying in the air. So we're going to be talking about the time that it's flying in the air. Okay?
When does something stop flying in the air?
When it
Thank
hits
you.
the ground. Yes, beautiful. Look at your
Yes,
blue
we
sheet.
did.
Look at your blue sheet. Where do you see something about the ground on your blue sheet? If you're taking notes. At your zeros, of course that's correct. So go ahead and plug that function into your table and find your zeros.
Miss Thompson, can a disk fly in the air for negative numbers?
No.
Can I do a disk in negative seconds?
No. So which answer can we eliminate? C, all real numbers. We know it has to be positive.
Is a disk going to go on forever and ever? Can I do 1,000 seconds?
No.
When in the world does the disk hit the ground?
When you plugged it into your calculator, what did you get?
I think Tyreek knows.
If I were you, I would ask X about those two numbers at the end. So is it 5 or is it 25? It's 5. That's correct. When you plug in 5 to ask X, it tells you it's 0. So from when it starts flying and after 5 seconds, it hits the ground. Amazing. Next question. Okay, this one's talking about end behavior. Is this a negative Nancy or a positive Patricia? A negative Nancy.
I remember I wrote down on my paper that A tells me if it's negative or positive.
Beautiful. So since it's negative and we're talking about end behavior, what are the ends of your graph doing? Are they increasing or decreasing? Jocelyn. Are the ends of this graph, are they increasing or decreasing? Decreasing. When I'm talking about it going down, decreasing, is that talking about my X or my Y? Anyway. Your Y. So we're looking for where it says f of x decreases. So one answer I know I can get rid of is answer choice C because it says increases. Look at all these other answer choices. This one has an increases for f of x, so I know it's not that. This one has f of x increases, so I know it's not that. Ding, ding, ding. We found the right answer. Yes, process of elimination. Any questions about end behavior? For quadratics, what you're really paying attention to is the f of x part. You're just looking at the y part. For quadratics, they should either be increase or decrease. Just depends on whether it's a positive Patricia or negative Nancy. Remember to draw a rough picture of your graph. Okay, for this one, which function is shown on the graph? So when we're talking about, who could tell me what my y-intercept is on this graph? Y-intercept. Oh. Negative 10. I know this by a different number. So this right here is negative 10. Which part of my equation, my A, B, or C, is going to give me my y-intercept? Look at your blue sheet. It's B when it's linear, but for C, is going to be c for quadratic. So it's ax squared plus bx, and it's the number that's all by itself will be negative 10. Which answer choice does not have negative 10 in the place of the c? C and D.
Miss Thompson, that's so weird because the constant in my linear equation is my y-intercept too.
What? Whoa, crazy. Okay, so the next question is about this 50-50 shot. What I would do if I were you is I would type answer choice A into my calculator. Type answer choice A in the table. Once you type it in, you do ask X, or you can just look for your zeros. You're just seeing whether the points are the same. And so once you find your zeros, if you typed in answer choice A, you should see that your zeros match. That there's a 0 at -2, and there's a 0 at 5. Next question. All right, so for this one, again, I see a word problem. So I'm definitely just going to go ahead and highlight my function. Ding, 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 I found it. Okay, so from here, it's asking about the time that the ball is in the air. So again, you're going to do the same thing where you're looking for your zeros.
Tristan, where did you end up finding your zeros for that equation?
See? So it's for in the air for about 3 seconds. And then G of t is in the air for about 4 seconds. So you have that one, this one's going down, and then somewhere between 3 and 4 seconds, it would hit close to 0, a little bit less than 0. But huh? No, those are right. F of t is the function. In the air for about 3. It's like between 3 and 4 seconds. So.
I think this one's the other one's between 4 and 5. So F of t would be for 4 and G of t.
Okay, so D. That's so weird because it hits between 3 and okay. So for that one, it would be D because it's about to hit the ground at 3 seconds for G of t. So we know that that one should be G of t is in the air for about 3 seconds. And your 0 for F of t, the function that you typed into your table, is at about 4 seconds.
All right, so take a picture if you would like to do the quadratic extra credit. If not, we are giving you time right now to do your practice quiz test. It's like a take-home quiz. It's really going to tell you where you're at and what last-minute things you need to figure out. So, this is going to be all your extra credit is due by 2:10. So make sure that you do that. You have the rest of class right now to work on your practice tests. Does everybody have one? That doesn't mean you're just like doing nothing, but you're working on your practice test. It is a quiz grade.